Hello, everyone. This is panel on observability, and we have wonderful panelists with us, multiple subject matter experts in the area. Today, we will be discussing multiple topics. For example, we will speak about 3 pillars. We will talk about challenges in the observability field. We will touch on the AIOps, MLOps subjects, and what is all the buzz about it. We will talk about big and small shops and the in-house solutions that different companies develop. We will touch on microservices and observability for this area. We will talk about myths in observability. And finally, we will finish with open telemetry. And before we start, I'd like to introduce our wonderful speakers today. And we can start with Partha.
Hi, everyone. I'm Partha. I'm currently working in Facebook, and my career has spanned the observability, diagnosis, remediation area. And I also spend a lot of time building the database and the platforms behind observability systems. And a lot of my career was in the large shops, including AWS, the public cloud.
Thank you, Partha, and welcome. Liz.
Hi, my name is Liz. I'm a principal developer advocate at honeycomb.io, which is a company that works in the observability space. And before that, I spent 11 years at Google as a site reliability engineer consuming observability solutions. So I'm excited to help spread some of that magic to the rest of the world.
Thank you, Liz. And I'm looking forward to that as well. Stephane.
Hi, I'm Stephane Davidovich. I'm a senior staff software engineer, senior staff SRE at Google, and I'm currently tech lead for several teams at Google who are building various monitoring and the solutions within the Google space. Prior to that, I've been working on various pieces of internal infrastructure and SRE for AdSense. So I'm looking forward to what I'll hear from this panel as well.
Thank you, Stephane. Gabe.
Hi, my name is Gabe. I've been working within observability at Microsoft for about the last 14 years. Really excited to be here and happy to hear and contribute to this panel.
Thank you, Gabe. And Richard.
Hi, I'm Richard. I own the monitoring platform and experience team at LinkedIn. I've been working in the space for quite a few years now. Including as a much smaller company before LinkedIn. So I kind of have experience crossing the small company and the big company domains.
Thank you, Richard. And now let's start talking about 3 pillars of observability. Very frequently, we speak about those as being the base of observability. So Gabe, what do you think about this?
Yeah, thanks, Darya. I mean, my opinion is they were, in the earlier days of observability, it was relatively happenstance that we've stumbled across, logs, metrics, and tracing as being the core aspects that are required to help diagnosability and visibility. And it's become formalized in more recent years as we've realized it. And as all things that are formalized, we tend to then pivot very heavily on that formalization. And we start seeing very hard boundaries coming up. And it's an interesting move, and I think it's necessitated by mostly the backend systems. The data models, the way we sample the data, the way we process the data is very different, and even store it and optimize it for cost perspective. But I think we've sort of lost it a bit in the interfaces and the experiences we provide customers. Those seams are very hard. The transitions between the pillars are almost non-existent or very rough in time correlation. So I think we're starting to see the sort of the next realization of that, in which we're trying to blur the lines with interface, things like having exemplars as part of the metric systems, where you can seamlessly jump between metrics and traces, and then traces to logs, where you can embed queries that deep dive you into logs and things like that. So I think that's sort of where we're heading. So the pillars still exist from a cost and optimization and systematic standpoint, but the consumption experiences tend to blur them now in going forward, frankly.
I'm not necessarily sure that I agree with that. I feel like, yes, in the past, the abstractions of logs and traces and metrics have been helpful, but they're not requirements to have observability. So I think we should probably back up and define what observability is. observability is the ability to understand what your systems are doing based off of the telemetry data that they're outputting. And that can include telemetry in the form of logs or metrics or traces. You don't have to have all three, right? They're not Pokemon, you don't have to collect them all. But you do have to have, with whatever signals you have, the ability to kind of slice and dice and analyze them in order to suit your needs, I think. I don't know, Gabe, how do you react to that?
Yeah, no, it's a good point. I think part of that observation, in my opinion at least, comes with the magnitude at which you're operating a bit. For example, I see that as a very solid principle. If you can collect all your data and if you could centralize it in a store and even operate it in a costly and timely fashion. But when you're, for example, having services that are doing 5,000, 10,000 requests per second, you don't want to collect all the logs for every request. You don't even want to construct the log statement. It might be too costly. And so having a cheap metric option to instrument that with, where it's just doing in proc, you know, +1, +1, +1 is necessary. So I agree with you, but I think it's not a one size fits all. It's more of a continuum. And as your service gets—
Yeah, I love what you said about kind of blurring the lines, right? Where you have exemplars, trace exemplars as a mechanism to get more granularity in your metrics. Or conversely, the approach that we've been thinking about a lot recently at Honeycomb has been this idea of sampling, right? Yeah. Where you're not necessarily keeping that counter and sending it to us, but you're saying, you know, 1 out of every 10,000 traces you send to us as an example. When we receive it, we know that that represents 10,000 like it, right? So we can still construct that metric. It's just a slightly different way.
Yeah, it is. But then you might also want separate trace or sampling semantics for logs versus, you know, things like, and then percentiles, you can't really sample those accurately even, right? Because you can't reconstruct histogram by that 10,000 multiplier. So again, I agree with, like, in principle, but I think there's ultimately somewhere where it starts to break down. And that's where I think these formalities came from. But they've been applied ubiquitously and kind of broadly.
Right, exactly, at all scales, right? Like if you're a small shop, you don't need to invest in a separate logging and tracing and metric solution. That's going to bog you down more than it helps, right? Like, as you're saying, it helps when you're at Microsoft or Google scale, but if you're at a small company scale, maybe you don't want those seams between the products because it's not saving you any time, it's not saving you any money. In fact, you're storing the data 3 times over.
Perhaps. I don't know where the cost factor comes into play, because I think that's another dimension outside of technology, meaning you're still storing a lot of data that may or may not be helpful to you in an observability standpoint. So I think there's another, you know, principle in play there that's not generally like embraced by engineers. Like cost isn't like something we're designing for generally as far as like consuming an observability solution. So I think that's where metrics and still dividing them up, you can get cheaper metrics than logs and traces and so on and so forth. So it's kind of, again, a continuum, I think, rather than a black and white. That's my opinion.
I'll give a slightly more complementary view to the 3 pillars. So first of all, let's try to define observability. For me, observability itself is a term that's overloaded and that keeps changing with time. It's an evolution from when we had LEDs on machines to watch the activity, all the way down to like fixes that automatically did get deployed and happen when something goes wrong. And it is an evolution. And in that evolution, there has been more and more ways of measurements and quantification and diagnosis of systems and microservices. So we have these 3 pillars. There are more than 3 pillars. In fact, I would also plug in events. There are people who use relational data models to represent telemetry data. There are people who use profiles to enable debugging.
Yes, continuous profiling, right? Yeah, it's not like, you know, these are the only 3 signals thou shalt use, right? Like it's an expanding set. We're figuring out new ways of visualizing this data.
Yeah, and coming from the big shops, definitely there are some interesting nuances of these, I would say, 5 pillars. Some of them we already covered. So the backend systems tend to be very expensive for some kinds of telemetry versus others. For example, if I had to build real-time low latency analytics on traces, which is a graph data model, especially when you have like thousands of nodes in the graph, it's going to be very expensive to actually do that. The same thing with logs, for example, log analytics, making it centralized and serving analytics in real time in low latency is a pretty costly proposition compared to metrics. On the other hand, from a user standpoint, the cost of generating this data is very different as well. It's the opposite really. To be able to create a metric as a user, as a customer, I need to really think of what this metric actually means when I use it, not when I generate it. And it's very different from logs where I can throw whatever I want and maybe I never use 99% of those log lines.
It's almost like generating log lines is too cheap.
Yeah, it's too cheap. And also the compute that is involved in generating a log line is less than metric because you aggregate and then generate a sample maybe every minute or 5 minutes. So
that's not always the case, right? Because logs, you have to offload all of those. Where metrics, there's a lot of libraries in proc that will just do computation. So I think, again, that's potentially true, but not always.
But if you think of the amount of engineering investment that centralized teams do to tune these libraries for cost, for CPU footprint and memory footprint, it's much more for metrics than for, let's say, glog, right? And so that's one thing. And also in the big shops, there is a overload of data in terms of number of metrics that a service emits, and people generally tend to be lost. Maybe a service has like hundreds of metrics and I only use 10 metrics at any point in time. And I never visit or revisit any of the others. So there is an information overload there. It's pretty hard to even understand and keep track of these data sets because it's an artifact of the pillars themselves and how easy is it to generate this data. Finally, I wanted to plug in ML ops a little because we talk about 3 pillars. To me, these 3 pillars or 5 pillars are really the equivalent of low-level language, like their assembly instructions, really to play with. But we have layers of abstraction that are getting built. In the machine learning world, the observability revolves around data and models. It's not about events, metrics, logs, traces. And that's an interesting artifact that's emerging as well in the evolution. So that's my take on this.
Thank you, Partha. Thank you, Liz and Gabe. And this question leads us to this next logical question. So when we build solutions for big and small shops, what are the challenges? Because we have different teams which are using those solutions. We have smaller teams or we have big corporations. So I'd love to hear from Richard. What do you think about this?
Sure. Yeah, this is a pretty big question. So there are a lot of different challenges, and it kind of starts from the ground up with the actual engineers. Whatever system you have in place, people need to understand it. That's the most fundamental thing. And we found as we kind of have grown at LinkedIn, the degree to which people understand the systems that we're using tends to kind of fade. It's not consistent across the board. One of the kind of advantages we have at LinkedIn is that our stack is very consistent in terms of our all of our Java stack has a very consistent set of like REST APIs that we can observe very consistently across the board. We can jump between services very, very easily. So that's a big advantage. But even with that, we still struggle to get a common understanding of how to observe things. Everybody always wants to kind of have their own dashboards, their own ways of observing things, their own ways of using logs. Even though we have a fairly common infrastructure, we should be able to do a lot better than that. So that's kind of what I see as like our next challenge. There's obviously challenges on the ground, like just the vast explosion, especially in the time series space that we've had over the last few years. The massive number of microservices we have thousands of microservices now, and it's the problem with time series metrics in particular is that they're very cheap, and the problem with things that are very cheap for somebody to produce means that they actually end up being very expensive. even when they're cheap to produce, you still end up with like literally billions of them, and billions of metrics still cost money. So so just like formalizing an understanding of like things aren't actually free. They might seem free, but you know, I know that Microsoft has similar challenges with their logging solution, which is amazing, and we've started using it as well. And it feels so free to produce logs to it that it's actually very, very expensive. it's like it's a huge.
I think this is a thing where there's a difference between large and small shops there, where at a large shop, you know, you don't actually see the bill for your logging usage or for your metrics usage, and it's just a challenge for that team to keep up. Whereas I can tell you that, you know, both at Honeycomb as well as with some of the startups that we work with, they very much are aware of what the cost is of that bill, of every kind of custom tag that they add that they wind up being billed for in their metrics provider, right? Like those are things that are no longer abstract. They are very, very concrete. And therefore you kind of have to think about and rationalize, what are the tools that I am using? Can I actually afford to do this? Should I be pursuing an all-in-one thing, or should I be, you know, getting one solution for each pillar, right? Like these are things that people very much have to think about because of that, you know, direct fee for service thing. Because at the end of the day, a startup is not going to have its own, right? Shouldn't have its own observability team, right? Like they should be focusing on what moves their business forward, and everything else is kind of overhead, right? So why build your own thing? But then that means that, you know, you're paying a metered service.
Yeah, and actually the problem with that approach is also that at some point down the track, you have to decide, as you cross that boundary between small and big shop, do you keep up with that solution, or do you get rid of that solution? And that comes with its own cost. So, and then that's a cost that the smaller shops don't definitely don't think about. We had a period at LinkedIn where we had to get rid of very quickly our logging solution, because the logging solution we were using moved from its own startup period into being a much bigger solution, and started charging literally tens of millions more, which was almost more than we were making in revenue at the time. And figuring out how to replace it was expensive. In fact, until Cousteau came along from Microsoft, we pretty much didn't have a solution for the first like 8 years that I was at the company. So there's a lot of kind of challenges in that space as well. I think we just crossed over a later question, but yeah.
Yeah, the in-house solutions is an interesting, because many companies try to build their own. Liz, what do you think about it?
I think that it depends on what kind of company you are, right? Like, you know, at one point in time, there's this kind of prestige associated with, you know, we are a big enough company to grow our own solution, right? Like, you know, with, for instance, Uber inventing Jaeger, right? Like with Google inventing Monarch and Dapper, right? Like, and all these things and publishing papers. I don't think that every company is a, you know, is a Google or a Microsoft or an Uber, right? You have to decide whether your expertise is going to be best spent building infrastructure, or whether your expertise is best spent working on product. So kind of, there's a tipping point, and I think that definitely the landscape, we think a lot about Wardley maps, right? Simon Wardley maps, and this idea of technology that is initially bespoke, novel, like eventually becomes commodity. And therefore, for a company that is starting with observability now, that aims to be large in the future, right? Like, I wouldn't worry too much about it, about building something in-house, because by the time you hit that point, either it'll be so commodity that it's cheap, or you'll be able to easily run your own in-house open source solution without having to build, you know, an entirely new data store.
Yeah, but at what point do you see that occurring? Because I guess, to kind of draw from your analogy, at the time Borgman or any of these other big company solutions, there were no commodity offerings. There were no open source offerings, frankly. This was, you know, 20 years ago at that point. And so it wasn't prestige, it was necessity. And I remember like using SQL to store metrics, which is obscene. Like a relational store is the most awful way to store metrics in the existence of mankind. And so I thought, my opinion is it's born far more out of necessity. And even today, I don't think we've reached that pivot that you're at least alluding to, in my opinion, where hosting your own open source is cheap and free. Like look at hosting Prometheus. Once you hit that scale pivot, you're basically a Prometheus operational house. Maybe you're not building a TSDB, but you're spending just as much operating a single box TSDB. So I guess
yeah, it's why I'm really excited about Chronosphere, right? I'm excited about Chronosphere. I'm excited about M3 for that reason, because they've taken that challenge, right? And in fact, the technology came from Uber and they figured out how to operationalize it, and now it's being commodified, right?
Also, I mean, we have the same thing with, you know, Prometheus trying to be multi-tenanted and scaled out, and there are still challenges, right? So I guess my question was more, when do you actually see that materializing in your mind? Because I think, my opinion, we're still several years away from that actually being a utility type of offering.
I wanted to chime in a little on the in-house one, but at least in the few big stuff that I have seen, one thing that's been happening, and we have mentioned this briefly, is the unification of all of these 3 to 5 pillars. As in, all of these different types of telemetry are emitted by the same process, by the same developer potentially, or the same team. And so what they expect to see when they actually use them for operations is they want to see a unified view of the service rather than a metric or a log line. And the challenge with creating a unified view is you have to do it in real time. You have to do it with very low latency. And it's a big data problem. It's a lot of data across 5 different databases potentially. And that's a challenge. That's a potential reason in my mind why we need to invest in slightly more in-house solutions, because modifying 5 open source solutions to behave like a data lake in some sense is a hard problem, and maintaining the metadata across them in a separate low latency system. Yeah.
And it's interesting to use the word challenge a lot, because as we've been talking about observability, we have been talking a lot about collecting the data that we use, you know, the 3 pillars, but logs and metrics and so on, as well as anything else not covered by those 3 pillars. But I think one of the interesting challenges there is, okay, you've collected a lot of data. We've already talked about that can be expensive. That can be mechanically challenging. Hell, if you're exporting too many log lines, maybe you even end up saturating your network. Whatever the case may be, there is a huge expense to it. But we haven't really talked about the use. And I think that is a big challenge in this field. It is extremely tempting to just collect all the data and hope, but because there is a real cost to that, we can't escape talking about how we're going to use the data, including making difficult trade-offs, saying we choose to accept the risk of not being able to debug or investigate or not notice a particular situation because the data necessary to get to that point is just too prohibitively expensive. There is a trade-off, and we've already talked so much about the cost side of the story. We need to talk about the benefits as well. And I think the big challenge there is actually becoming dogmatic. We've already heard in the past things like SLO-based alerting is the only good alerting, even though that is patently false in many real situations. But you might start dismissing data available to you. It's not SLO related, therefore I don't care. We've seen discussion about error budgets around various metrics and how they can be interpreted to making decisions at large or small scale, whether it is in a situation when you're debugging a particular problem in your application, or whether it is in a situation where you're trying to take the aggregate information from your microservices or even from your multiple products, if you're a bigger shop, and aggregate them towards a larger decision process, maybe strategic change for priorities for the next couple of years. And getting to that point is remarkably difficult. It is difficult to connect the dots between the time series that you collect every minute, or your log entries, and the answers that you need to get about what do you do in the real world at small or large scale.
Thank you, Stephane. Richard, what do you think about challenges?
Yeah, I think just to kind of build on the kind of real world side of things, we have this other challenge where one of the things that you're looking at aren't necessarily in the observability system that you're currently looking at. So not everything that you're seeing is coming out of the telemetry from that system, right? Like we have business metrics coming in separately, and the problems that we have basically fall into 3 or 4 different categories. It's usually related to some kind of deployment, some kind of code release, or some config change that somebody pushed, or it's some totally external event that is only detectable out of our business metrics. And so one of the kind of remaining challenges we have is figuring out how to better combine our observability systems, because those metrics aren't even collected, or that telemetry isn't even collected as part of our system. It's a totally different system where we need to infer what's going on.
A good point. And with all the challenges about poor quality data and obviously unrealistic expectations, there is this magic word, AIOps, and many think that AIOps will come and solve all our problems. So Partha, do you think it will really solve all our problems?
AIOps is an interesting term. So there is a startup ecosystem, a very large startup ecosystem that has been using this word and using it in different contexts. Maybe just to formalize it a little, I think it's a collection of processes and algorithms, largely like black box machine learning algorithms to improve and automate operations. It does include processes as well, if you see some of the startups looking at it. So AIOps, in my mind, it exists very differently between startups and the large companies. I think the large companies embraced AIOps earlier in general because they have seen problems that they can automate. There are 2 kinds of problems that I think the reason I'm doing this is because AIOps does not really solve one of them. There's one class which is recurring problems that operators keep seeing, and there's a definite need to automate, and all that's left is like finding easy ways to automate and quickly automate a large number of these. And then there's a long tail of problems which are hard to diagnose, leave alone automate, and which are hard to diagnose accurately. So thinking of the challenges in solving these 2 buckets of problems, there's definitely the part about, do we have the right monitoring data? Do we have the right logging in place? Do we have enough metrics so that we don't underfit a machine learning model, or we don't overfit a machine learning model so it starts predicting inaccurately? And part of that in the big stops is that we do have an overload of monitoring data sets, and we don't have enough metadata to keep track of these data sets, their usage, their semantics, their meaning. And so discoverability of telemetry data, then interpretability, explainability, all of this becomes hard, which makes it even harder to have AIOps running well. And leave alone that, adapting to changes in the system, the architecture, the code base, the configurations over time, even organizational changes that change the telemetry itself and operations, it makes it very hard to use AIOps. But all of that said, I think I have seen environments where automation and automated diagnosis, in addition to remediation, made a big difference to operations in a large scale setup.
Thank you, Partha. I believe Stephane have an opinion on this, right?
It's interesting that you talk about building the AI models, because it feels like that has been a big focus of a lot of the work and a lot of the let's say research and preparation. Mm-hmm. But the model itself is insufficient unless it is considered in the context of the usage. What I really mean by that, if you take a statistical method or a machine learning model and apply it for alerting, you might make many people very unhappy. Make many people very unhappy because you will page them at 4 a.m. But that same process, that same model, that same statistical method might give you useful information if you use it to aid the debugging. So one thing that AIOps really needs to figure out for itself is not only the technology, which is often at the forefront of the discussions and the presentations, but also the suitability of chosen technology to the use case and really mix and match. Regrettably, this might land you in some conclusions that maybe a particular use case will not lend itself to these methods altogether, at least not yet. But that is the challenge that we might need to bear. I'll only add that there is a paper by Todd Underwood and Steve Ross about AI or ML in ops, and it is quite an interesting read, and it touches on some of the topics like explainability in a lot more detail.
And there will be another panel organized just for AIOps. So I really encourage all the attendees to attend that panel as well to learn more. And Richard, what's your take on AIOps?
So I think that it's really applicable to a few domains and not greatly applicable to some others right now. Some things it's really good at is change detection, very, very clear stepwise changes. We can infer pretty well what the causes are and what to do about them. But what it does really badly at is giving any kind of repeatable decision, like the chances of the same thing happening in our system even twice is relatively rare because we tend to try and fix things, and so the exact same thing happening again is relatively rare. So great for change detection, less great for like helping with auto-remediation, which I think we'll get onto again later. But I think the biggest challenge is actually probably trust. And I think Stephane kind of like touched on this. The problem is that if I'm getting woken up at 2 o'clock in the morning and I created the alert, I have a lot more tolerance than a machine telling me that I have a problem at 2 o'clock in the morning and it being wrong. And that creates like a false sense of security for what we currently have, and a lack of trust in the systems that we could have, which makes it actually very difficult to try out these things, right? Like people just don't want to receive alerts at 2 o'clock in the morning from a machine if they're not like very, very close to 100% certain that it's going to be correct, which is a very human problem, I think. At the end of the day, it's not really something that a machine would be worried about, but it's something that humans are very worried about. So that just creates a huge disincentive to launch things like this at large scale. And like a lot of the attempts we've had at this have failed for that kind of reason. The teams writing them are very happy that they've got to kind of 86, 87%. And that's like 13% wrong, right? Like that's not nearly good enough for a human. What did I just say? 13? Yeah. So that's a very real challenge that we have at the moment.
Yeah, the big challenge is that the quality of the data we build models on is not always perfect, which makes models not that perfect as well. And this makes us move into microservices domain. So now that we are using microservices everywhere, and it obviously impacted observability field. Gabe, what do you think about it?
Yeah, I mean, microservices are like one of those things, working on the backend systems, like you kind of love and hate them, meaning you love them in that they brought a new attention to the observability field due to the complexity of running microservices. Like this is our biggest sell in recruiting, is people are super interested in observability now because they work on microservice systems and they understand why it's so important. But you hate them in the same light in that with containers, I'll kind of bundle that with microservices, you get this very high ephemerality aspect, meaning, ephemerality is kind of the enemy of dimensionality and metrics and explosion of data, because you get these things that come and go rather than sort of fixed labels. And so they presented a lot of challenges to the systems as well, to be able to handle this scale and the amount of data they can generate. And the only other thing I'll add, and I'll kind of yield the floor on the topic, is I think the other big impact they've had specifically that I've observed is on the field of tracing. Again, sort of the first, quote unquote, to go back to the pillars, two pillars that were always around, if you will, were metrics and logs. And then people started to realize the importance of tracing because, you know, when a transaction touches 1,000 nodes, you don't even know where to go get the logs necessarily, or how to view the metrics, or you don't even have a metric that can represent the full transaction. So these have to be derived from traces. So there's a lot of value it's brought to the field and the acceleration of tracing solutions, which to me is still the most immature of the three in terms of products. Even looking at like a Jaeger OSS variant versus a Prometheus, you can see how much activity is on them versus one another. It's still developing quite heavily. So, yeah.
Yeah, I think one thing that I would add is that when we have microservices, it's really, you stop being able to use centralized tools, right? Like the developer experience fundamentally changes. Additionally, people are making changes at a much more rapid pace, right? Like it's no longer, you know, a singular deployment that you can watch. You might be affected by dependencies, you know, 3 upstream or downstream of you changing. You have to be able to find that. No log line is going to find that. No metric is going to find that. You really need to see, where did this request start failing? Why is it failing? What's happening, right? Like kind of that decoupling creates these like really interesting and fascinating cognitive challenges of how do we keep many teams flying in formation? And I think that if everyone is using the same observability tooling, then it means that people can correlate and see that in one system rather than having to kind of cross all these boundaries and talk to a bunch of different teams.
Maybe this is where open telemetry will help us. What do you think?
Yeah, I mean, open telemetry, you can tell people are very hungry for it, right? Like you could, it's a very relatively new endeavor that is being encountered. Many of the specs are still just being formulated into version 1.0. And you could see all the corporations starting to already glom on and even adopt it before it was solidified. So you can tell there's a hunger for it very, very early. But like we're only scratching the surface even at this point. We're at the SDK level. We haven't even talked about consumption. And consumption is really the vendor lock-in problem and the ability to move your service around and be a bit more free. Sure, I can instrument my service, but the thousands of alerts or views or dashboards that I've built are still vendor specific or language specific or whatever you want to say. So I think it's a great effort that started, and I think it'll do a lot for the SDK in the near term. But we haven't even, I believe, touched or even gotten to the point to where it's going to be a ubiquitous solution to give, like, again, going back to the utility or commodity analogy, where people don't care, you know, how the electric comes to their house. They just care that it's there and they have a plug, and, you know, short of some country differences, the plug will always work. And we haven't even gotten close to that from a full end-to-end standpoint.
Yeah, I think that first step is really, really key, though, to have data portability so you don't have to redeploy every service, so you don't have to re-instrument all of your code when you change providers. And I think the other pieces will come with time as we define what are the key capabilities that people should expect from these, you know, services that are becoming more commodity and less bespoke. What should we expect with regards to, you know, infrastructure as code to standardize dashboards? I'm actually really excited about OpenSLO for that reason, because it kind of standardizes. This is what the SLO definition is. And then people can take that from vendor to vendor, right? Like, I think those things are really going to help us along that journey of standardization.
Yeah, I agree. One question I'd be curious to hear your thoughts on, like, even where we're at with OTel and the SDK, it's still very heavily relying on the fact that we have to make it very extensible, because the time series databases or technologies underneath it support different histogram formats or support different capabilities, because on the other end, the consumption experiences are different. So do you actually believe, even with what we have, that we do have that portability? Because most of the advanced capabilities that you want to take advantage of are extensions, which are, again, vendor specific.
I think the core workflows that people expect are things like, can I define my service level objectives? Can I define based off of, you know, my metrics data or my trace data, right? Can I query those traces to find the subset of traces that match my needs, right? Yes, there are going to be differentiation areas around, you know, how do people find anomalies, right? Like that's something that is an exploratory thing that's not necessarily going to be standardized in the code, but like, what are my common dashboards? How do I query? What are the common visualizations I do on these signals, whether they be metrics or traces or logs, right? Like, I think that those are things that we can think about standardizing into a common data model.
So one question for Liz and Gabe. On open telemetry, I was wondering, if you look at ML ops, the abstractions are very different from the 5 pillars. How do you see open telemetry evolving? Do you see better abstractions that are more friendly towards the usage side rather than the emission side, where we silo into 3 pillars?
Yeah, I think that OTel's mission is around generating telemetry in a vendor neutral format. We are deliberately agnostic about the backends, what their capabilities should be for querying, because that's kind of not where we're focusing our time on as a project. We have enough scope, right? Like, we have tracing as a very mature signal. We have metrics as a less mature signal within the open telemetry ecosystem, right? And then we have logging and eBPF as things that people are working on, right? Like, so I think that there is a lot of interesting work ahead, but I don't think that OTel has to do it all. Right? Like, open telemetry. Telemetry is in the name, right? There's a reason for that.
Yeah.
Yeah, I think, I mean, the maturity level I see still a little different, even in the fact that, sure, tracing, the core SDKs are mature, but for example, none of the semantic conventions are solidified. So sure, you can go forth and instrument, but how do you describe a distributed, like an event hub or a Kafka queue message or any of these to stitch them together, HTTP request or whatever? That's still in beta, basically. It's an experimental format. So to answer your question, I think first we have to get a standard cemented to where we can go forth and observe. And AIOps, I think, actually would be the one doing more of the adaptation. Like, the way I look personally at AIOps is the value that it can bring outside of like the SLO oriented, which is like the human driven and the human created alerting, is it should be able to like look at this sea of data and make sense of it. Like, that's the dream, right? Because we produce all this data, 99% of it's not touched. Something should be able to make value of it, and that's AIOps, and that's the promise it gives. So can it be achieved? We'll see. But
depends on the size of the shop, right? Like, at a company like Microsoft, you have the data set that's large enough, right? Whereas if you're a small company that is, driving maybe 50 to 100 queries per second, like, yeah, whether you're going to get interesting signal is more hit or miss.
No, completely agree with that statement. It's definitely, everything is a gradient. I don't think there's going to be a, hey, do it this way and you'll be set, kind of solution. But AIOps, to me, I think should adapt the schematization, adapt the standards, which I think is what your question was.
And there are a lot of myths in this area. So Gabe and Elise already touched on some of them. And sometimes auto-remediation is seen as a solution for everything. Let's just auto-mitigate everything which comes, and we don't need to ever touch in production. So Partha, what do you think about it?
Yeah, so it's an interesting myth. So I'm more of a proponent of auto-remediation, and I'll explain it a little more. But I will preface it by saying that for me, the key insight to auto-remediation, first of all, is to be able to accurately diagnose or root cause a problem and then accurately map it to the right set of actions. And for the diagnosis part, it has to start with domain knowledge. We cannot really use a machine learning black box model that doesn't really understand the intent, the operational knowledge and wisdom that other people, that operators actually bring in their day-to-day job. So when we build diagnosis system, we really have to think of starting with domain knowledge. We encode some rules, and then something like reinforcement learning, for example, could improve that over time and adapt to changes in the system and in operations itself. So given that, auto-remediation is something that has existed for a long time. It's just been considered harder in the microservices world. For example, the vanilla TCP that started in the 70s and 80s, right? The transmission control protocol. Its observability component is to watch the network and to make sense of whether something is going wrong and adapt to it. Same thing with load balancers in the network layer, routing on the internet, routing protocols that are built by vendors, the video transmission like YouTube. where it's observing the network and adapting the rate of the video, CDNs, and leave alone these, even like closed loop systems like Tesla, for example, self-driving cars. All of these are auto-remediating systems, pretty advanced. And I think they basically tell us that, yes, we can automate a much more complex microservices environment. Just that we have to watch out, we have to make sure there's enough domain knowledge and safeguards in place so that it doesn't take unnecessary actions.
Richard, what do you think?
I mean, I think I think it's another one where people's perceptions of what can be solved with auto remediation is just a little bit too exhaustive. The problem with auto remediation is you can solve significant domain of problems, but the things that you can do to solve them tend to be pretty small, right? Like you can detect capacity issues, you can remediate capacity issues, you can take broken hardware out of production, you can replace it, you can you can replace VMs, you can do things like that. What you can't do without significant extra input is is the change I just introduced something I can roll back? Because sometimes changes can't be rolled back. They can only be rolled forward. They should be able to be rolled back, but that's not always the case. And the main real problem is that there is no run book of problems that you can just collect and say the next time this happens, we'll remediate it, right? Because the problem is, again, if you're doing the other part of this problem, right, which is postmortem and fixing the problems, those problems shouldn't be happening again. And what you don't want is for auto remediation to become a crutch. You don't want it to be the thing that the engineering team just relies on until they fix the problem, which might end up being in a year's time, right? And then you take it out, and that's no longer a useful remediation anymore. And it's not a useful remediation to anybody else's problem, because all of these problems are domain specific, which is kind of back to Partha's point, right?
And there's a challenge in looking at self-driving cars that I mentioned. Like it is a complex problem to drive a car. However, throughout the entire journey from A to B, the car does this on a continuous basis. In contrast, when you're doing incident remediation and response, for the more common things like, hey, maybe my hard drive has exploded, this can be automatically remediated and shut down the machine and move on. But as you go to less common events, it starts to look a lot less like every moment I'm inspecting the road and whether I'm complying to the traffic restrictions and regulations. And it starts to look a lot more like aliens are attacking, and what do I do now? And so our incidents are really covering the gamut, right? A few years ago, I believe SREcon had the topic of black swan events. And our line of work covers the gamut from aliens are attacking down to oh look, another hard drive has departed. And understanding the fitness might be a requirement for us to actually succeed in stuff like using the observability data.
Great point. Actually, I was about to say that one of the key tenets of building such a closed loop is, one, the diagnosis has to understand that it cannot really generate a diagnosis if it doesn't have enough confidence. And second is, we cannot take an action if we don't have enough confidence either. So that confidence notion has to be inbuilt the way we humans look at the problem.
Thank you very much. Thank you very much, everyone. And we are running out of time. So it was wonderful to have you all here. We covered a wide range of subjects, and we will be on Slack answering all your questions. So please follow up with speakers on Slack. Thank you very much. Bye.